Welcome to Lesson 3 of Module 4 Ecosystem Dynamics. In this video, we're going to be looking at the first lot of videos about evidence for past changes. And in this video, we're going to be focusing on paleontological and geological evidence of past changes. Specifically within this, we're looking at Aboriginal rock paintings, rock structure and formation, as well as ice core drilling. So ecosystem dynamics really is just a way for us to recognize that ecosystems are constantly changing. They are complex and there's many interactions that can affect how an ecosystem works. A shift in one component definitely leaves a ripple effect that goes on to many other components, and this can lead to changes within the whole ecosystem. If we do see an imbalance within an ecosystem, we're usually seeing the destruction and loss of biodiversity, and this sometimes can be caused by invasive species. Within a stable ecosystem, any small changes are balanced out with no major effect on ecosystem processes or, in fact, its structure. Ecosystems that we refer to as stable generally have a higher biodiversity than unstable ecosystems. When we are looking at ecosystems, one of the ways we can look at it is through the negative feedback loop. And this is how populations are maintained within a stable ecosystem. And this negative feedback loop is a self-regulating system. Positive feedback is where we see an increase in a component of an ecosystem, and negative feedback decreases a component of an ecosystem. And this feedback loop is a way we see what happens when there are changes and increases to populations. Disturbance is an event that causes a temporary change within an ecosystem, and this may be the loss of individual organisms, ecological disturbances, or any human activities that may be taking place within an ecosystem. If we have a resistant ecosystem, these are tolerant to disturbances, and they can remain the same over a long period of time, mainly staying around its average state. A resilient ecosystem does in fact return to its normal structure and function after a disturbance. And the intermediate disturbance hypothesis proposes that high and low levels of disturbance reduce the species diversity. And if there is only intermediate level of disturbance, it can maximize species diversity. So when we start to look at the geological evidence, we do start to piece together puzzles that do relate to the Earth's crust, and they provide a lot of understanding to us. Such things as fossils, mineral deposits, and also rock strata, and these are the horizontal layers of the Earth, can add to the information of what Earth was like in the past. Rocks do preserve information about the biotic components of past ecosystems, and they have a record of the conditions of the environment throughout time. They contain evidence of changes in climate, volcanic activity, atmospheric oxygen levels, sea levels, and shifting land masses. So just a reminder about the different types of rocks. So if you did Year 7 science, you would recognize each of these three types. So igneous is formed when magma or lava cools and crystallizes. Sedimentary rocks are formed when small particles of weathered rock are compacted or cemented. And metamorphic rocks form when existing rocks are exposed to extreme heat or pressure. Environmental conditions do in fact alter the structure of rocks, and they can leave characteristic rock formations that we can see many years after. When we look at ice core drilling, we need to drill into layers of ice, and this is usually in the form of a glacier or an ice sheet. An ice core is a cylinder-shaped sample of that ice. Due to the layering of snow and the compression that this causes, they do in fact provide information about abiotic and biotic factors in past ecosystems. The ice furthest away from the surface is the oldest, so just like rock layers, and the ice on top is the most recent. However, the bands or the layers are much more difficult to see the further they go back in time. These do contain evidence about past air temperatures, precipitation rates, and atmospheric gases, as they are trapped within the layers of ice, and they can be examined once the layers of ice corresponding to a time frame is isolated. So here we can see how we can measure the atmospheric carbon dioxide in ice cores, and then we can see the changes in temperature that would have occurred during that time as well. The human records do, in fact, help us to understand what happened in the past. And we can, in fact, examine historic artefacts of Indigenous Australians, which allow us to collect information about Australia's natural history and gain insight into the changes that occurred in the ecosystems of Australia's past. So one of many ways which we can do that is through rock paintings. And these were created by Indigenous Australian people, and they can date from modern time back to 28,000 years ago. The ancient art usually depicts the types of animals that were abundant at the time, where they lived in the past, and the changes in animal communities over time. So scientists do, however, have to understand what is depicted in the artwork and the age of the rock, and which is why it's really important for scientists in these situations to collaborate closely with the local Aboriginal communities. It is ideal that we could take a sample of the paint and date it. However, much of our work is to try and preserve the painting, and a sample of material overlying the artwork can sometimes be taken, including sediments or mud. One of the major regions within Australia is the Kimberley region within Western Australia, and it is known as a major rock art landscape. Within these areas, we see images of changes in geography and climate, as well as changes in animal and plant life, not only within the drawings themselves, but with the samples of materials that we've been able to take from there. Some of this information that we're going to look at within rock paintings is really important when we piece together our next bit of evidence and how we work together to, in fact, date rock paintings. We are going to look at this much more closely and how it relates to our local community within our classroom. But just wanted you to look at this because this is the type of rock paintings that we are specifically looking at within our focus area. And these are the naturalistic types of rock paintings. So we see that sometimes there are life-size animals, including fish, plants, and some human forms, that can be painted on the rocks. And by doing this, we can actually try and determine what animals they were in the past. So we are going to look at this in more detail within our classroom. Thanks for watching Lesson 3, and make sure you tune in to Lesson 4.